All right, so we're at lesson 117. 3 more to go after this, guys, which we'll cover next week. But today we're talking about two concepts here, equations with x squared and then the Pythagorean theorem. And then there's a demonstration or a theorem proof for the Pythagorean theorem, which I'm going to let you read through on your own because it's we're just not going to do it in this video today. Some things in math we just skip over because they're not necessary for us at this time. So that's one of those things. Anywho, x squared. So we know that x, when we talk about x squared equals 4, we know that there are two solutions for this, right? Because we know that 2 squared equals 4, and we know that negative 2 squared equals 4, right? Because that squared multiplies both the 2 and the negative symbol. So this says, from this we conclude that we can solve an equation such as x squared equals 4 by taking the square root of both sides, right? Let me show you what that looks like. I'm going to do it down here. So x squared equals 4. If we're solving for x, we're going to say square root, the square and the square root cancel out, and we get x equals, and the square root of 4 is 2. But we also know that it could be, it could also be negative 2. True? That we could have also been squaring a negative 2 to also get the number 4. So it says we use this symbol plus or minus 2 when it could be either positive or negative 2. It says in here that it's important to note that when we use this radicand symbol, the radical symbol, excuse me, that it indicates that it can only be a positive or principal square root. So the square root of 4 can only be positive 2. All right? So when we have the square root, it can only be the positive, but if we're squaring, it can be positive or negative, okay? So the answer when we have a radical symbol can only be positive, but when we're squaring, it can be positive or negative. So now we're going to look down at some examples. So p squared equals 16. So if we take the square root of p squared, we get p, and if we take the square root of 16, we get 4, right? So that means something times itself twice gave us 16. So is it true that p could either equal positive or negative 4? It does, okay? Because we know that positive 4 squared is 16 and negative 4 squared is 16. Now the second example says p squared equals 42. So if we take the square root of both sides, that means, so we take the square root, the squared and the square root cancel out. Now can we take the square root of 42? It is not a perfect square, so we can't, but we know there is some value that could ultimately satisfy this number. So the way this looks is we say p equals plus or minus the square root of 42. So we know that something positive times something positive equals square root of 42, or something negative times something negative equals the square root of 42. Okay? So you'll attack this a lot more in Algebra 1. Remember, as we're getting to the end of the year, they are throwing more things at you that are getting you ready for what's coming next year. So enjoy while it lasts, I guess, right? The easier stuff. This next lesson is one of my favorites. And I wish we were in class together to explore this, because this literally, as an adult, blew my mind. No one explained this to me as a kid. Did you see me just catch the pen? That was so good. Anyways, we're going to be talking about the Pythagorean theorem. And Pythagoras was I believe he lived in Alexandria, which was part of the Greek Empire, and he was a mathematician. And all those years ago, 3,000 years ago or whatever, he came up with what's called the Pythagorean theorem. So he studied triangles, and he found a universal truth about all triangles. Now, let's talk about some of the features of triangles before we get into the genius that Pythagoras found. But triangles are three-sided shapes. Pythagorean theorem is only dealing with right triangles. We call this the leg of the triangle. We call this the leg of the triangle. The long side of the triangle is called the hypotenuse. Hypotenuse, okay? So that's a vocabulary word you need to memorize. You're going to deal with it a lot. All right. The Pythagorean theorem states that the area of a square drawn on the hypotenuse of a right triangle equals the sum of the areas on the squares drawn on the other two sides. That's a lot of words. Let's look at what that means. If we have a right triangle that measures 5 by 4 by 3, let me show you what happens. If we draw a square here, okay, and we find the area of the square, and we draw a square here, and we find the area of this square. So how many boxes are here? We have 9. How many boxes are here? 16. And then if we draw a square here, how many squares do we have here? 25. Is it true that 9 plus 16 equals 25? Yes, this is a universal truth about right triangles. So, the formula for the Pythagorean theorem is a squared plus b squared equals c squared. The legs of the triangle, the other two sides, are a squared and b squared. It doesn't matter what order you put them in. C is always the hypotenuse. Okay, the hypotenuse is always C, all right? So because of this, when we're doing geometry, if we get a problem with a triangle that's labeled with two sides and we're missing one, we can always find out the missing side. So let's look at some examples. I don't want to erase this drawing, it's so cool. So what you can do at home if you want to is you can get some graph paper, you can draw some right triangles, and then you can test this by cutting out the squares of each length. So let's look at this first example. Shows us a triangle. Remember, they always have to be right. The back is 4, the hypotenuse is 5, and the leg is labeled A. Now, we're going to need to find the problem. Let's see how it's worded. It says, given the triangle with the lengths of the sides as shown, use the Pythagorean theorem to find A. So we know the Pythagorean theorem is a squared plus b squared equals c squared. Okay, for A, we're just going to leave a squared. For b squared, we're going to do 4 squared. And c squared is 5 squared. Now, PEMDAS tells us that we have to take care of these exponents. So we get a squared. We can't solve this yet or simplify it at all because we don't know what a is yet. 4 squared is 16. 5 squared is 25. All right? So now to get a by itself, we're going to subtract 16 on each side. Those cancel out. We're left with a squared equals 25 minus 16 is 9. Now, we're left with a squared equals 9. Remember, to isolate the variable, we have to do the inverse operation. The inverse operation of squaring something is finding the square root. What undoes squaring? Square root does. So we're going to find the square root and the square root. Okay? The exponent and the square root cancel out, and we're left with a and the square root of 9 is 3. Remember, it's called the principal square root, right? Excuse me. So then let's test this, okay? Is it true that 3 squared plus 4 squared equals 5 squared? 9 plus 16 equals 25. We have 25 equals 25. It checks. It's true. All right, I think we get one more example, and we're going to work that out real quick here in the video. And it's got another right triangle, and they put it on like a weird orientation to test you, but remember, you're always looking for this right symbol. So we get 4, 5, and P. Now we have to find P, right? And then we're going to get another one, so I'm going to just draw it out while I have the book. 7, 9, and M. All right, so for this one, our formula, a squared plus b squared equals c squared. Now, c is labeled p. It doesn't matter what it's labeled. As a mathematician in this level at Algebra Half, you should be able to know that the hypotenuse is the long side of the triangle. So they're going to label it whatever they want to. So we're going to say the two legs are always a and b, so we have 4 squared plus 5 squared equals c squared. 16 plus 25 equals c squared. See, 16 plus 25, we have 6 and 5 is 11, excuse me, so 41. So we have 41 equals c squared. And then to find that, we need to take the square root of each side, right? So we're going to take the square root of c squared, and that cancels out. So we're left with c, which just means hypotenuse. And then we get the square root of 41. Plus or minus the square root of 41 is going to give us our measure of c squared. Now, this equation has two answers, a positive square root of 41 and negative square root of 41. But only one of these answers can be the answer, right? So we don't have to include this because we know a measurement can't be a negative measurement if it takes up physical space, right? So the only one to satisfy would be the positive. Now let's look at this last one. We have a squared. This is a 9, by the way. A squared plus b squared equals c squared. Okay? So a squared, we're going to do 7 squared plus b squared equals 9 squared. We get 49 plus b squared equals 81. Minus 49 on each side. We get b squared equals 81 minus 49. 8, 7, 11, 9, 10, 11, 3, 43. Sorry. We get 2 and 3. That was quite a doozy. Okay, then we take the square root of each side to isolate that variable. Square root and square cancel out to give us b. Do we know the square root of 32? It's not a perfect square, so you just get to leave it as the square root of 32. Now here we don't have to enter the plus or minus because we know that it cannot be a negative number. So use your formula. Hypotenuse is always c squared. Fill in the numbers, isolate the variable to find the unknown side. If you have any questions, please let me know.